Now, in 12.2, we're going to be looking at the inverse of the functions and whether they are one-to-one. A one-to-one function is when each x value corresponds to only one y value, and each y value corresponds to just one x value. What that mumbo jumbo means is, first of all, it is a function if on the domain, I'm looking at the x's, each x it's only used once. So that's what we'll call it a function. If each x is only used once. Now we call it a one-to-one function if it is a function to begin with, but also on the range, each range is used only once. In this case, it is not a one-to-one function. It is a function because each x is used once, but it's not a one-to-one because I see a y value that is used more than once. So as soon as you see a repetition of the y values, it is not a one-to-one. Okay. So looking at my second example, B, each x is used only once, so that makes it a function. Each y is used only once, so that makes it a one-to-one function. Okay. So now we're going to start using what we call inverse. If I have the function f, I'm going to do to the -1. I'm using a -1 as an inverse, not as an exponent. We'll take a look at it in a minute. So here it says, decide whether each function is a one-to-one. If it is, find the inverse. So I know the x values do not repeat because it's a function, but in order for this to be a one-to-one, the y values will not repeat. I see a repetition here. There's another repetition as well, but as soon as I see a y value that repeats, it is not a one-to-one function. So it says decide whether each function is one-to-one, and this one is not, because the y values, there is a repetition on y values. It says if it is, so if you did say yes, find the inverse. But we said no, so we stop at that. Looking at G, it is a function because the x values do not repeat. Then I ask myself, is it a one-to-one value? I look at my y values. The values do not repeat. So in this case, I say yes, it is a one-to-one function. Now, because I said it is a one-to-one function, I'm going to find the inverse. So we're going to say the G inverse. So remember, I'm using that -1 as an inverse. What I'm going to do for my inverse, I'm going to swap the x and the y values. So the 0.31 become 1,3. The 0.02 becomes 20. The 0.23 becomes 3,2. And the 0.40 becomes 0,4. Once again, all I did was I swapped the x and the y values. And we call it a one-to-one function because if I look at it right now, it is a function. The g prime is a function because there's no repetition of x. And it's a one-to-one because there's no repetition of y's. Now, if we have it as a graph, my figure at the left is a function. My example A is a function. And then when we have a graph, we can do a vertical line test. If I cross any line, I cross my figure only once. That is called a function. But we also have the horizontal line test, which you guys can see here. I'm crossing the point, my figure at more than one point, in this case, 3 times. But I'm crossing my figure more than once, so that is not a one-to-one. On my example B, I can do multiple horizontal lines, and I cross each of my functions, I only cross it once. So that one is a one-to-one. So if you can do a horizontal line test and you cross the figure only once, it is a function to begin with, you only cross it once, then it's a one-to-one function. If you're able to come out with a horizontal line that crosses the figure more than once, it is not one-to-one. So let's take a look at this. Decide whether each equation represents a one-to-one function. If so, find the equation that defines the inverse. My first one, 2x plus 5, I remember y equals mx plus b. I gave you guys the formula before, y equals mx plus b. That gives me the equation of a line going up. So give or take, it looks like that. I can tell it is a one-to-one function. So because it is a one-to-one function, so it says decide whether each function represents a one-to-one function. I'm going to say yes, it is a one-to-one. So if so, because I said it is a function, find the inverse. What I'm going to do, the f of x, we're used to y and x's. So I'm going to write this as y equals 2x plus 5. Instead of f of x, I'm going to use y, just because we're used to use x's and y. To find the inverse, the x and the y are going to swap. So I'm looking at this as x equals 2y plus 5, right? The x and the y swap. And now solve for y. So get the y by itself. My plus 5, I'm going to move it to the left. X minus 5 cannot be combined. So I'm just going to write that x minus 5 is equal to 2y. To get the y by itself, let me divide everything by 2. So I get that y is equal to x minus 5 over 2. Now that I have the y by itself, I'm going to switch it to the terms of f. So I'm going to call this f inverse of x. Remember, I changed it to y just to work on it. F inverse of x is equal to x minus 5 over 2. Once again, change it to x and y. Solve for y. Once you solve for y, switch your y to inverse. In this case, f inverse or g inverse or whatever that function is called. Now, let's take a look at example B. Now, example B, y equals x squared plus 2. We just worked that in the previous example, on the previous chapter. That looks like a parabola open up. I can do a horizontal line test, and I cross my figure more than once. So this is not a one-to-one function. So it says decide whether each equation represents a one-to-one function. I'll say no. Example B is not a one-to-one function. If so, find the equation that defines the inverse. I'm not going to find the inverse because it's not a one-to-one function. Now, looking at C, everything to the third power, give or take, looks like a little snake. It is a one-to-one function, so I will find the inverse of this one. So yes, because I can do a horizontal line test and it passes all the time. So I'm going to rewrite this as y equals x minus 2 to the third. Right? I just replaced, instead of f of x, I called it y. Now for the inverse, the x and the y are going to swap. So x equals y minus 2 all to the third. And solve for y. I'm going to get rid of the exponent by doing the cube root. Right? The cube root is going to get rid of that cube powered. So I have that the cube root of x is equal to y minus 2. To get the y by itself, let me add 2 to the left. So I have that the cube root of x plus 2 is equal to y. Now that I have y by itself, I'm going to switch this to f inverse of x is equal to the cube root of x plus 2. I want to show you guys something. Here to have the function that was given, the three functions that we just worked, I found the inverse of each. Even on the middle one, I was like, let me take a look at the inverse. There's something I want to show you guys. So on the first one, if I was to graph 2x plus 5, I get a graph that looks like that. If I was to graph the inverse, I get another line that looks like that. But let me graph the line y equals x. The cool thing of the line y equals x is that it looks like a mirror line. My original function and my inverse, it looks like they rotate or they reflect. They reflect over the y equals x. What that means is, imagine if that was a piece of paper and I fold it right on top, right on the line y equals x, right on the green line. If I was to fold it right on that, my two graphs will overlap. Now, looking at the second example, x squared plus 2, it looks like that. If I do the positive or negative square root of x minus 2, it looks like that. If I was to do the y equals x line,